Hello, welcome to another TensorFlow tutorial. My name is Ian, and today we're going to actually be building our TensorFlow or neural net in TensorFlow. So, start off, I just found this little data. It's wine quality of white wine, and let me show you right now. What it basically is, it has a bunch of data, and we're going to classify how good that is on a scale of 1 to 10 based on the data it has. So our rows are going to be like fixicity, volatility, citric, all this. And our label is going to be quality. And what we're going to do is try and build a neural network to predict the quality. Now, this data isn't very good. A lot of them are like between 6 and 7. Also, there's only like 5,000 pieces of data, so I'm not really expecting much to get out of this neural network. But I just wanted to kind of show how we shape the data. So I should have closed that. So I just look quick pandas here. Just drop the quality. That's our input data. We got the last value, and that's going to be our labels. To categorical is basically we're going to turn numbers into percentages, I guess you could say. So instead of getting a network to predict a number, we're gonna like a number 10. What we're going to do is actually get a 10 dimension array, and at the index of the number we're trying to look, we're going to put a 1. And so how I like to think of this is when we're labeling it, we're 100% sure. Next, I split it with a test split. This is on scikit-learn or sklearn. And we're going to take our data, split it a third, and we're only going to use 2/3 to train it, and we also save 1/3 to test it. Now, why we do this, we don't want to. We want to get an accurate prediction of how our model's doing in real life data. So we have to make sure the ones we test for accuracy are completely independent from what we use to train it. Okay. Let's go down. So here's the kind of quick architecture I built. Number input. So you see, come on. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 columns as our input, and number of classes is going to be our output. It's on a scale of 1 to 10, so we have 10 output. And then I got 2 hidden layers, and it's going to be 20 dimensions each. Okay, so let's get starting on our neural network. Remember, the first step, we have to calculate our prediction. So let's go X. This is what we're going to send into our neural network. So remember, we use placeholders. We got to set the data type. Let's do float 32. And now we're actually going to make the shape of the data. This is the shape of the array we're going to send in. So we get none, and then number of inputs. So basically, you're going to see the none. It's like a variable length. It doesn't really matter what size this is, so we can just leave it none. So that way we can feed in testing data, training data, or prediction data of varying row length. But that's all that means. So this will be, we'll put our labels in this, y, set the data type as float 32, let's go. And our shape, again, we'll do none. And the number of columns, I guess you could say, is number of classes. Okay, so let's get some variables. Weights. I'm going to throw these into a dictionary just so it's easy to read. Input. Let's go layer 1. So we have a matrix with a number of input, and we want to get it to output this layer 20 columns, I guess you could say. So let's get tf dot variable, and we're going to initialize this stochastically. Remember, that's just random dot random normal, and then we just feed in the shape that we need. So we're going to have to multiply by the number of inputs, and the other one is the number of hidden one. So the output when we multiply x in layer 1, it should give us our size of hidden layer 2. Okay. Let's get a column. Okay, let's do layer 2. And we can even borrow some of this. Okay, we're actually going to do number hidden input 1, and we want it to output number hidden output 2. And let's copy this one more time. And this will be our output. And again, we'll just do that, and number of classes. Okay, so that's going to be our weights. Now let's get our biases. And we're going to do something similar. Except we're only going to do one dimension. So this is what we're going to multiply the output of our x times layer 1, and then we're going to multiply or add this one. Okay, so let's build our neural network. So layer 1, so first thing we do is matrix multiply. And what are we going to do for layer 1? It's going to be x, our input data, and our weights at layer 1. Okay, then we're going to add our bias to that, tf.add. And what we're going to add is the output of this one, as well as our biases at layer 1. Okay, and then we're going to throw this whole thing into an activation function. I'm going to do relu, and this just takes out negative numbers. So this is our output of our first layer, and it should get a shape of our number of rows of our data and our 20 number of layers. That one. Okay, and I'm actually going to reuse a lot for layer 2, but obviously I'm going to have to change these to layer 2. And also, I'm not going to be adding the input data, I'm going to adding the output of our first layer. Okay, now we get our prediction, and it's also going to be, so we're going to send in our output of layer 2, our weights are going to be our output, and our biases are going to be the output as well. These are the variables here. Okay, I'm not adding an activation function on the prediction because, remember step 2, loss. The loss I'm using is for prediction, and this softmax cross entropy with logic. This is gonna calculate our softmax for us. So make sure if you're using softmax cross entropy, you don't add a softmax here. It's assuming you're not doing it. Cross entropy, it's kind of like another loss function. So you remember mean squared error. This is one just used better for classification. And logics are probability outputs. So we can even write logics here. But So our logics, we're going to send it as a prediction, and our labels are going to be what we labeled it as, what the data we know as. I was also pretty sure I was going to screw this up, so I just copy and pasted. Here's our accuracy. We're going to use this to predict how well our neural network did. But so this was step one. Step one, calculate output of our graph. Step two is calculate our loss. Step three, we're going to use our optimizer. And I'm just going to use gradient descent again. So optimizer equals tf.train gradient descent optimizer. And I didn't get it. Did I do learning rate? No. Learning rate we got to bring into our optimizer, remember? 0. And remember, what do we want our optimizer to do is minimize. What do we want to minimize? Our loss. So it's going to be pretty similar to the last one we did with the line. Just this is our neural network. Neural networks are not really that complicated. They're just matrix multiplication, so this shouldn't be too difficult. And where are we now? Okay, so let's start a graph. Global variables. I think I spelled that right. So we're initializing our graph for the graph. Now let's get a session going. tf.session as sesh. And first thing we got to do is initialize our variables. Okay. So now, like the last one, we're going to run our optimizer. But we're going to run a couple things at a time. So we got a list of these, or fetches, I guess you call them. First thing we're going to calculate optimizer, our loss, as well as our accuracy. And the data we have to feed in, so our x, that's our input data. So this is our actual data that we got from our data set. And it's got to be a dictionary. Sorry. And our y, and the value is going to be our labels. Okay, so this is going to give us our optimizer, our loss, and our accuracy. Optimizer, actually we don't really need this. So our loss, I'm just going to call it L, and accuracy. So this is going to unpack all of our loss and our accuracy, and we're going to print this out. So we don't need any special thing to print these out, so let's print loss is what else? I'll just do it in 2 lines. Print accuracy is okay. Now, right now we're only running it once, so let's just run it about 5,000 times or something like that. For I in range, let's do it 200 times. And I'm not really expecting much from this graph because the data was not very good. But let's see what happens. Okay, I probably should have formatted that a little better. Okay, well, it's compiling. Our loss is slowly going down, it looks like. And what's our accuracy? 44. Accuracy doesn't seem to be doing that much. Da, 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 da. Yeah, I formatted this really annoyingly, sorry. Yeah, so it looks like it's working, it's training. Let's see how we got at the end. About the same. Loss isn't too bad. 40% accuracy. Hopefully that's just because it's hard to do. Not that I made it wrong, but yeah, I guess that's it for today. That's everything. Like, subscribe, leave a comment, and enjoy the rest of your day.